Hello, everybody. Today's lesson is on section 11.4. So if you could go ahead and open your textbook, we're going to start on page 612. And the focus of 11.4 is on proving triangle similarity. So you may remember when we were proving congruent triangles, we had a list of ways to guarantee that we had congruent triangles, and so we had things like SSS, SAS, AAS, and let's see, ASA and HL. And then if we had 2 angles or 3 angles, that did not guarantee that the triangles were congruent. If we had SSA, that did not guarantee that the triangles were congruent. So now we're going to do something similar. We're going to create a list like this, but relating to triangle similarity instead of congruence. And so this says that if we have 2 angles the same, which by the way is the same as having all 3 angles the same, so you could say AA or AAA, because if you have 2 angles the same, then you would technically have all 3 angles the same because they all have to add up to 180. So for example, if you had a 40 degree angle and a 60 degree angle, if you had a 40 and a 60 or something like that, then the other angle would have to be 100 in order to, or sorry, would have to be 80 in order to add up to 180. And so that would be true in the other triangle as well. Okay, so this is saying that if we have 2 pairs of matching angles in 2 triangles, then those 2 triangles must be similar. Because if 2 angles are the same, then all 3 angles are the same. And the triangles would be exactly the same shape, but they could be a different size. Okay, so similar, again, means that they could differ by a dilation. So they don't have to be the same size triangle, they just have to have all the same angles. Okay, and by having the same angles, that makes all the sides proportional as well. Okay, and so skipping forward to well, let's take a look at example A on page 613. So to prove that these 2 triangles are similar, we would have the vertical angles are congruent. So there's a pair of matching angles. And then since these sides are marked parallel, then alternate interior angles would also be the same. And so those 2 triangles are similar by AA. And so you have angle A is congruent to angle D by the alternate interior angles theorem. You have angle ABC is congruent to angle EDB because they're vertical angles. And so then that gives you triangle ABC is similar to triangle DEB by AA. Okay, and so first we proved that those are similar, and then it says find BE. So once we have the triangles are similar, then we can use proportions to find missing sides. So if I call this side X, BE is X, so we'll do BE over a side that we know, like BD. That should be the same as, so look at BE is the first and, the second and third letter, so that matches up with BC. And BD is the first and the third, so that matches up with the first and the third here, which is AC. And so we can set up a proportion like that with corresponding pieces. So the ratios of corresponding pieces need to be the same. And so we are trying to find BE. We know BD is 54. We know BC is also 54. And we know AC is 36. Okay, so now to solve for x, we can cross multiply. So we get 36x equals 54 times 54. And so then x equals 54 squared over 36. And that is 81. So x equals 81. Okay, for problem B, we're trying to find RT. First, we need to show that these two figures are similar. And so these angles are already marked. And then R is an angle that's in both triangles. Okay, it's in the small triangle and the big triangle. And so we can say in the given diagram, angle R is congruent to angle R. R is shared by both triangles. And, oh wait, let's see. Oh, it's given in the diagram that angle RSV is congruent to angle T. So that's given, and then R is shared by both triangles, so R is congruent to R by the reflexive property. So by the AA similarity theorem, triangle RST is similar to triangle RTU. So now we can set up a proportion. We're trying to find RT. So if we call that X, we can set this up. They already set up the proportion here, but basically what they're doing is they're saying that in the big triangle, RT, that's first and last, over ST, which is wait, I think they have the letters wrong because triangle, there is no triangle RST. So let's fix their letters first. So maybe it's correct in your book, but in mine it says RST. So that should have been RSV is similar to triangle RTU. Okay, and so now we have RT, which is this side, over, let's say, TU. And so RT matches up with RS, and TU matches up with SV. So that's the proportion that I'm setting up. A little bit different than the one the book set up, but they're both going to work out the same. Now, if we fill in the information, RT is what we're trying to find. TU is 12, RS is 10, and SV is 8. So when you cross multiply, you get 8x equals 120. And so x equals 120 over 8, and that is 15. Okay, if you use the proportion that the book suggested, that would be RT over RS. RS is 10, TU is 12, and SV is 8. So they did, what they did is they did long side over short side equals long side over short side. And when we cross multiply there, we also get 8 RT equals 120. So you get the same answer, RT equals 120 over 8, which is 15. So there are lots of different ways that you can set up the proportion as long as you do it in a consistent way. So I did my proportion, I did long horizontal over long slant equals short horizontal over short slant. And so you can set it up either way. I use the letters in the similarity statement to match up the corresponding pieces. Okay, so go ahead and try numbers 6 and 7 on page 614. Pause your video and try those out, and first show why the figures are similar, and then find the missing pieces. And this one we want to find AB, and this one we want to find PQ. So go ahead and pause your video, and then press play when you're ready to check your work. So for number 6, we can see that since these lines are parallel, the corresponding angles would be congruent. So those two angles would be congruent, and those two angles would be congruent by corresponding angles. So the two triangles are similar by AA. So we can say these are similar by AA. And now we can use a proportion to find the missing pieces. We're looking for side AB, so if we call that X, look at how I'm going to set this up. I'm going to say 6 over X, so that's short side over long side, equals 9 over 15, short side over long side. So short over long on the right side equals short over long on the base. So you could say short right over long right equals short base over long base. Okay, there are different ways to set that up, but when you cross multiply, we should always get the same result, even if you set up your proportion differently. So I would get 9x equals 90 and x equals 10. And so AB is equal to 10. And then for problem 7, we have two right angles. So there's a pair of matching angles. We have angle P and angle T also congruent. So the triangles are similar by AA again. So you could say triangle, let's see, QST is similar to triangle, we have to get it in the right order. This would be R, then the right angle S, and then the marked angle T. Okay, so those triangles are similar by AA, and then we could say, let's see, I'm going to tip this this triangle TSQ. I'm going to tip it up so that it's like this, so that we can tell what matches up. And so this is 9, and this is 15, and so we're trying to find PQ, which is X. Okay, so if I match up 9 over 12, that's small base over big base, equals small height 15 over the big height. The big height is actually X plus 9. See, PQ is not really a side of any triangle, but if we match up the corresponding sides, this and this match up. And so we have to use that whole side, 9 plus x. And so now we can solve for x by cross multiplying. That would be 9x plus 81 when I multiply this way equals 180 when I multiply this way. And so then 9x equals 99 and x equals 11. So that means PQ is equal to 11. Okay, and then on that same page we have two more similarity theorems. In addition to AA, if we have three sides that are in the same proportion, SSS, so notice that that doesn't mean the same thing as it did when we did triangle congruence, because when we said figures were congruent by SSS, all three pairs of sides had to be exactly the same. Now we're not saying that the three sides have to be exactly the same, we're saying that they're proportional, which means when you set up a ratio of the three corresponding sides, you should get the same ratio. Okay, and then SAS, again, the two S's mean those two sides are in the same ratio for the two S's, and then the angles have to be congruent. So if two sides of one triangle are proportional to the corresponding sides of another triangle, and their included angles are congruent. Okay, so the A has to be congruent, but the S's are not congruent, they are in the same ratio. Okay, and we'll do some examples to demonstrate that. Okay, so on this example at the top of page 615. We want to show that the three ratios are the same. So if I do the long side here is 12 over the matching side in the small triangle, that's 8. Is that equal to the left side over the left side? Is that equal to 6 over 4? And in this case, this is 3/2, and this is 3/2. So they're both equal to 3/2. So they are in the same proportion, and the angles in between them are already marked congruent. So this gives us the S's, and then the angle between them gives us the A. So those are similar by SAS. Okay, and then for example B, we have 3 pairs of matching sides. We should match them up in order. So I could do the shortest side over the shortest side. Is that equal to the longest side 10 over the longest side 15? And is that equal to the medium side 10 over the, or sorry, 8 over the medium side 12? And in all three of those are reduced to 2/3. So all three sides are in the same proportion. They're proportional. So that gives us SSS. And so you're given 3 pairs of corresponding side lengths and 0 congruent angles. So you try using SSS. And so we can say triangle GHJ is similar to L, let's see, MN by SSS. Okay, and so go ahead and try on page 616, try numbers 10 and 11. Pause your video, give those a try, and then press play when you're ready to check your answers. For number 10, we have a pair of matching angles already, so that gives us the A. And then we match up the shorter side over the shorter side, 3/6. And then the longer side over the longer side. Are those the same? And yes, they are, because they're both equal to 1/2. 1/2 equals 1/2, so that gives us the 2 S's. So we can say triangle ABC is similar to triangle, let's see, that would be FGH by SAS. Okay, we've got 2 sides in the same proportion and a pair of matching angles that are in between them. Actually, that angle is not in between those, so this is not, this is actually SSA, and so that is not going to guarantee the triangles are similar, and so we'll say not necessarily similar. We do have 2 pairs of matching sides and an angle, but it's not the angle in between them. They might be similar, but we don't have enough information to tell. Okay, and then number 11. Looks like is also SSA. We have actually this is SSA as it's given, but since they're right triangles, we can find the missing side using the Pythagorean theorem. So if you use the Pythagorean theorem, that side would be 4, and this side would be 6, and then we can show that they are actually similar, because short side over short side equals medium side over medium side equals hypotenuse over hypotenuse. Those all reduce to 1/2. So we can say triangle MNO is similar to triangle GHJ by SSS. So that one was a little tricky because you had to use the Pythagorean theorem to find the third side. So SSA doesn't work, but since they're right triangles, we were able to use the Pythagorean theorem to find the missing sides and then use SSS. Okay, and now I've got some more examples for you. So you'll probably need a piece of paper to write these out. And so for these, we want to state if the triangles are similar, and if so, how do you know they're similar? By what reason? So remember we have three ways now of proving that triangles are similar. We have AA, which is the same as AAA. We have SAS, and we have SSS. So those are the three ways that we can prove that triangles are similar. Okay, so for problem number 1, we're given 3 pairs of sides. So if we match up the smallest side, 24, with the smallest side, 56, is that the same as the medium side, 27, over the medium side, 63? So we'll put a question mark there. Are those the same? And is that the same as the longest side, 36, over the longest side, 84? Okay, so we want to reduce all of those. 8 goes into these first two, numerator and denominator, so that would be 3/7. And 9 goes into the second fraction, top and bottom goes in 3/7. And 12 goes into both 36 and 84. That goes in 3 times and 7 times. So they're all equal to 3/7. So we can say a triangle PQR. PQR goes from short to long. So from short to long would be FE. And then P. FEP by SSS. Okay, and then in problem 2, (13/65) and 13/70. Are those equal? Definitely not. 13/65 is not equal to 13/70, so these are not similar. Okay, we have an SAS situation, but the sides are not in the same proportion. They're not proportional to each other. Okay, go ahead and try now on your own. Try problems 3, 4, and 5. If you think they're similar, write a similarity statement. And if you don't have enough information, then say not necessarily similar. So for problem number 3, we have another pair of matching angles that are vertical angles. And so these would be similar by AA. So CDE is similar to CMN by AA. Triangle CMN by AA. For number 4, again, we have vertical angles. So those are going to be similar by AA as well. And so BCD is similar to triangle, let's see, it goes from the marked angle to the 50. So we'll go marked angle to the 50 would be BQR by AA. And then for problem number 5, we have vertical angles again. And so we want to match up shortest side over shortest side. equals longer side over longer side. Are those the same? And this is 1/7, and this is also 1/7. And so since those two sides are the same, that gives us our SS, and those two angles are the same, gives us the A in between. So we can say triangle PQR is similar to triangle let's see, we want to match up small side with small side, so that's going to be PEF by SAS. Okay, now in problems 7 and 8, this will give you practice writing the proportions. So the triangles, the given triangles are similar, and so use a proportion to find the missing piece in each one. Okay, so go ahead and pause your video, try 7 and 8, and then press play to check your answers. Okay, in number 7, I'm going to call the question mark X. So I would have right side of the small triangle over right side of the big triangle equals the left side of the small triangle over the left side of the big triangle. So I did small over big equals small over big. And so then when I cross multiply, I get 6x equals 7 times 36. Divide both sides by 6, and you get x equals 42. For problem number 8, if I call that x, we know these two triangles are similar, and so we have to use the matching pieces. So VW has to match up with QR. So we're going to have VW over QR equals VU, that's first and second, over first and second PQ. And so VW is X, QR is 5, VU is 28, PQ is 7. So then when I cross multiply, I get 7x equals 5 times 28. Divide both sides by 7. X equals 20. All right, that's it for today's lesson. Have a great day, everybody.